I guess I'm just gonna get started. Hello to anybody who's clicking on this video. Um, it's very much what the title is going to be, whatever I choose it to be. We are doing a Euclid contest together if you want to, otherwise, you can just watch me do it. Um, I'm doing these mostly for fun because I did them so often in my youth and I realized I actually enjoyed them. And, growing older, you don't really get pushed to do these kinds of things because their target demographic is not you. So I figured I'd just make time out of my day and do it myself. And so, um, I had previously recorded the 2025 version and then scrapped the whole recording, which is why we are doing the 2023 version. Because I feel like if I'm going to record, I want it to be my first time doing it, so that's why we're doing the 2023 version. So hopefully this time I'm actually satisfied with however I end up recording and editing this video, but you'll see, I'll show it on screen. We are doing the 2023 Euclid contest for funsies. I am not like the official answer maker. I'm not anybody you should be consulting for advice. I just think it'd be fun to do it, and maybe if you want to, you can do it with me for fun. But yeah, let me get my pen. But we are doing the 2023 Euclid contest, which is the grade 12 level math contest here in Canada. Well, more specific, it is available throughout North America and South America, but for me at least, and the university, they are both based in Canada. And so if you want to do them yourself, you can go to cemc.uwaterloo.ca, which is their website, and you can find all the contest papers, the contest solutions, as well as just the prizes if you're a younger kiddo who would like to participate to see what they can win. But in general, here are the rules we are going to be following. Naturally, since we are at home and there are solutions, we can't exactly follow them all to a T, but what we are going to follow is the time limit. So you can see down there I have a timer that I am going to set up because our time limit is 2.5 hours. I am recording this, right? Yes, I am. Okay. And so the way this contest works, since this is the first time I'm making these, I don't know if I'll explain it for the next ones, is there are 10 questions, and most of them will have a short answer part where all you do is give them an answer, and there will be what's called a full solution part, which I perceive as a written answer part because they care about your process as well. And so yeah, so we are going to be, for the most part, following along these rule sets. Obviously, I have my own little scientific calculator here. You can't see it because, well, I'm a VTuber and not a webcam YouTuber, but yeah. So feel free, to get set up to do this with me if you would like, but if you don't, just enjoy the ride, I suppose. I'm gonna say it here and I'm probably gonna say it again at the end of the video, but thank you to anybody stopping by. Uh, I hope this video meets your expectations, and if it doesn't, feel free to share any constructive criticism. Um, I am very much looking to improve my skill set related to just everything in the YouTubing world and the VTubing world and just everything like that. I'm just scouring my brain to see if there's anything else I want to say. Probably not. Yeah, okay, you know what? Let's just set up the timer and go. And if I have anything else to say, I guess I'll just say it at the end of the video. So, yes, the timer works. Okay, so we are going to just get started. This is when you would be in your classroom and you would be handed the book and allowed to open them. So on my screen here, I have my scratch paper side and then the contest paper side. Let's go through the instructions. Please read the instructions on the front cover. We did that already. Write all answers in the answer book. We don't have one because we're doing this at home, but it's okay. We'll do what we can do. Place your answers in the box with light bulb questions, so the short answer, and for the questions with like a person writing on paper, oh, they're left-handed. We want to have a organized solution. So, diagrams are not to scale, calculators are allowed only for numerical calculations. Okay, so let's just get started. I've spent 1 minute explaining this already, but I don't usually run out of time. In contests, I just run out of patience. So let's see how long it takes for me to crack this time. The first question 1a, is the average of n, 2n, 3n, 4n, and 5n is 18. What is the value of n? Because it is the average, if the average is 18, that means 18 is equal to n plus 2, n plus 3, n plus 4, n plus 5n, all over 1, 2, 3, 4, 5 terms. So it's all divided by 5. Because that is what the average is, right? It's the sum of all of them divided by the number of terms. So if 18 is equal to, well, that's 1, 3, 6, 10, 15. That's a total of 15 n, nope, not m, n over 5, which makes 18 equal to 3n. N is equal to 6. Pretty simple. Like I said, if anybody wants to do this with me, you're welcome to do it, but obviously I'm going to be solving as we go. So you can mute me, you can follow along, enjoy the video however you want it, because I'm making these videos however I want them, so who cares? Who cares? Anyways, I need to stop rambling. I need to actually do these problems. Suppose that 2x plus y equals 5 and x plus 2y equals 7. What is the average of x and y? So we need to find x and y first, and the easiest way is, since we have two equations and two variables, we can use what's called a system of equations, or solving for a system of equations. How do we do that? Well, we choose one equation to keep, and then we use the other one to isolate for one variable in terms of the other. So what that means is, on this side, we're going to take that x and we're going to isolate it by subtracting 2y from both sides. So now we have x is equal to 7 minus 2y, which means we can take this and substitute it into a second equation. So then it becomes 2 times x is equal to 7 minus 2y plus y equals 5. And so if we distribute it, we get 14 minus 4y plus y equals 5. If we group our like terms, we get negative 3y. Subtract 14 on this side, subtract 14 on that side, and we get negative 9. Divide both sides by negative 3. We get y equals 3. That only gets us one of our variables. The question is asking us for the average of x and y, so we need to go back and find x. So we can take either equation, it doesn't really matter. So let's go back to x plus 2y equals 7. Now all we do is we take our y and we substitute it in, so now we've got x plus 2, 3y, not 3y, 3 equals 7. I hope this is legible when I go to video edit this, because obviously I write quite small. I'm rambling. I'm still rambling. That's crazy. So x plus 6 equals 7. Subtract 6 from both sides. X equals 1. And so the question, you'd have the box average of x and y equals, well, x plus y over 2 is the average, which means it is 4 over 2. Our average is 2. So that's the boxed of 1b. I guess I'll probably put, like, if I get it right or wrong in, like, post-editing, but obviously I don't know right now. So let's go to 1c. The average of t squared, 2t, and 3 is c. If t is less than 0, determine the value of t. Okay, so let's give this a try. C. So average, obviously, is 9, which equals t squared plus 2t plus 3 all over 3. So this probably would be a question of quadratic solutions or solving a quadratic equation due to the t squared. What I would do is I would multiply both sides by 3 to get 27 on this side, just so we're not dealing with an annoying fraction. And then when we're solving a quadratic equation, we want to have one side be equal to 0. So it would be minus 27 on this side, minus 27 on that side. And so we would get negative 24. And now this is just solving a quadratic equation. You could manually do it. I'm probably gonna, like, you could do the x equals negative b plus or minus the square root of b squared minus 4ac over 2. Yeah, you know what? Let's do it that way. Just because it's more clear for the judges, even though there is no judge. I am the judge. But let's say I was doing this in a contest. I probably would do it like so, just because rather than guesswork, this looks a bit better to the people grading you. So b squared is 2, so that would be 2 squared minus 4. We have no a value, and so that's 1. C was negative what again? Negative 24. Negative 24. Right? Yes, all over 2. I forgot the a here, but that's 1. And so x equals x equals negative 2 plus or minus, well, let's use a calculator because that's a bit much. It would be 4 minus 4 times, it would not be minus, it would be 4 plus, well, no, it would be 4 minus negative 24 times 4, which would make it a plus, and therefore square root of 100 over 2. X would be equal to negative 2 plus or minus 10 over 2. X would equal, well, we'd have negative, well, it would be minus 10. So it would be negative 12 over 2 or 8 over 2. X would be negative 6 or 4. And the question specifies that t is less than 0. So that means basically we're looking for a negative integer. So our answer would be x, or in this case t. So t equals negative 6. Just like so. And that would be our answer. And a process, I suppose. Editor me. Check to see if it's right. It's going to be a huge hit to my ego if I get the early questions right. Obviously, you know, the later questions I'm not going to do so good. But if the early 3 questions, if I get them really wrong, I'm going to be really disappointed in myself. Ooh. Anyways, don't think about that. Think about succeeding. If Q is the midpoint of the line segment with this and this and that, what are the values of P and O? Okay, this is actually a pretty simple question. So essentially what it means is Q's points, 5 and 3, let's say this is x2 and equals 5 and y2 equals 3. Then P then essentially what that means is x2 is supposed to be equal to the middle of the two x values. So it should be 1 plus o over 2, and a y value, y2, is supposed to be equal to the average or the midpoints of the two y values of the ends of the line segment, I guess. And so it would then be p plus 5 over 2. And so 5 equals 1 plus o over 2. If we multiply both sides by 2, we would get 10 equals 1 plus o. Oh, no. O would be equal to 9. And for y2 would be equal to, why did I do it like that? 3 is equal to p plus 5 over 2. Multiply both sides by 2, and we would get 6 equals p plus 5. Subtract 5, you would get 1 equals p. And so it's just asking what are the values of p and o. So p is equal to 1 and o is equal to 9. And that's our answer for 2a. New page. 2b is, sorry, I'm just periodically checking on the recording just to see if I didn't screw anything up. But, so no answers open on the side, don't worry about that. I don't see the point in cheating when I'm doing this of my own free will. But, okay. Ramble aside, 2b. A line with a slope of 3 and another line with a slope of -1 intersect at p, which is 3, 6. What is the distance between the x-intercepts of the two lines? That's not too bad. So first we want to construct our two lines because we're given, I'm pretty sure, all we need, because most equations can be formed, not most, all linear equations can be formed using the point slope method. And so let's do that. So we know one has a slope of 3, and we know the other one has a slope of -1. So b is our placeholder for now. And so what we're going to do is we're going to take our point P, and we're going to substitute its values into the equation to find b, aka its intercept. So, not the intercept we're looking for though, because it's looking for the x-intercept and b represents the y-intercept. So, anyways, I'm gonna stop yapping now. So, if we substitute in our x and y values according to the points, we would have 6 equals 9 plus b. B would be equal to -3. And on this one, we have 6 equals -3 plus b. B equals 9. And that only gets us our two equations. So now we have our two linear equations fully complete. Oof. 9x plus 9. And so now we actually have to find the x-intercept. So the x-intercept is when y equals 0. So we just take our y's and we make them 0, and we find the x value that makes, well, this equation valid. So in this case, it's actually pretty simple. We add 3 to both sides to isolate our x, and so we divide, and our x would be equal to 1. And on this one is also quite simple. -x, divide both sides by -1, we would get 9 equals x. And so our x-intercepts are 1, 0, and 90. It's important to specify that they are in points because obviously x-intercept is something on the Cartesian plane, so you want to do things in Cartesian plane notation. Okay, we'll probably need more space for 2c, so let's start a new page. 2c. With some value of t, the line of the equation is perpendicular to the line with the equation of such and such. Determine the point of intersection of these lines. Okay, if I recall correctly, two lines are perpendicular if the slopes are the reciprocal of it. Yes. The negative reciprocal. Right. It's the negative reciprocal. So that means in order for y equals 2x plus 7 to be perpendicular, the other must be -1 equals 2 times t, because that's what a negative reciprocal is. They multiply to make 1, and then it's negative. So it would be negative, nope, it would be divide by 2, so it would be -1/2 equals t. So because of that, our mysterious equation is -1/2x, and since it specifies that it's tx plus t, since it specifies that it's tx plus t, our b value is -1/2. 1 second, quick water break. I'm definitely not used to talking as I solve. But yeah, so now that we have our two equations, we're looking for the point of intersection. That means basically if we set the two equations equal to each other, or basically we substitute one y with the other, we would be able to find at what x value they meet. So let's do that. So -2x plus 7 equals let's move this way and that way. Because then we're left with a nice 2.5x, because negative becomes positive on the other side, but on this side we're left with -7.5. So I guess negatives were just inevitable. And then we divide both sides by 2.5. We would get x equals, I'm pretty sure that's -3. Let me double check. The amount of times I've gotten something wrong just because I thought I knew it. Yes, so x equals -3. But we're not done yet. We're looking for the point of intersection, which means we also need the y value. So let's take our y equals 2x plus 7, because that's nice with whole numbers, to substitute in our -3 value that we found, and we would get y equals -6 plus 7, y equals 1. And, you know, if you had spare time, and I guess we do, I would do this again with the other equation. 1/2, y equals -1/2 times -3 minus 1/2, y equals, that would, two negatives cancel out, so it would be 3/2 minus 1/2, y equals 1. Both are fine. So our answer would be, we found our x value of -3 and our y value of 1. And that would be like a boxed answer. Even though it's a long written question, I like to box my answer. Yeah, so that's 1 and 2 done. Yippee! Timing wise, it's okay. Realistically, you should be spending more time on the later questions, so we're technically a little bit slow, but you know what? It's about the journey. It's about the journey and my choice to do this of my own free will and my limited free time. Yep. Okay. Positive. The sum the positive divisors of 6 are 1, 2, 3, and 6. What is the sum of the positive dividers of 64? Well, that's not hard, is it? So 64 has no factors aside from 2, right? You take out 4, you get 16, and then that's 4, 4, 2, 2, 2, 2. This is prime factorization, by the way. So 1, 2, 3, 4, 5, 6, 6 2s. So 2 to the power of 6, which I guess we could double check. But yeah, 64 is just 2 to the power of 6. That means, in terms of divisors, we have 1, we have 2, we have 4, we have 8, we have 16. Do we have 8? Yes, we have 8, 16, 32, and 64. And that's it. Because we don't have any other divisors, right? So we can't mix and match anything other than just adding a new 2 every time. So yeah, I guess we just add them up. So we have 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. It equals 127. So that's our answer. Editoring me, I better get this right. I better get this right. There's no way. I'll just hush now. I won't say anything more. Okay. Ian wrote 4 consecutive integers on a whiteboard, and Lexi came along and erased one of the integers. Fian noticed that the sum of the remaining integers was 847. What integer did Lexi erase? Okay, so first off, I'm just gonna divide. This is 3b. Divide the 847 by 3. And the remainder will dictate what number it erased, because our consecutive integers would be +1, n plus 1, n plus 2, and n plus 3. So if it's one of these two combos, it would have no remainder. And if one of either n or n plus 3 was erased, there would be no remainder, because it would be perfectly divisible by 3. If n plus 1 is erased, well, it would be obvious, it's just, I'm thinking now, it would be 3n plus 5, and so it would have a remainder of 2. Meanwhile, if this one were erased, we would have 3n plus 4, and therefore we'd have a remainder of 1. I think. So let's just divide 847 by 3. Okay, so we have 282 with a remainder of, well, my calculator doesn't do it. Oh, it does. Okay. Yes, with a remainder of 1. Because it has a remainder of 1, that means it's this scenario. No. It has a remainder of 1, so it's this scenario, because 3n plus 4, 3n plus 3 plus 1. So that's our remainder. That means the integer they removed was n plus 2. N is 282 in this case. No, it isn't. It isn't quite an integer in this case, because of this plus 3. And so if we have a if we have a 847 equals 3n plus 4, it's 843 equals 3n. 843 divided by 3 is equal to 281, although I could have guessed that, equals n. The integer we removed was n plus 2, so our, I guess, answer is 281 plus 2, 283. I do not like this new GoodNotes updated between like today and the last time I opened this app. I don't like this new update. It's like obviously barely there, but I don't like it. I guess that's what I say with every single update these days, though. Anyways, I need to stop rambling. I need to stop rambling. An arithmetic sequence with 7 terms has the first term d squared. So d squared is term 1, and a common difference of d. The sum of the 7 terms in the sequence is 756. Determine all possible values of d. Okay, so term 1 is d squared. The next one is d squared plus d. The next one would be d squared plus 2d. And then d squared plus 3d. All the way to, it should be d squared plus 6d. Because it's 7 terms. Okay? What does that mean for us? That means we have 7d squared plus 7, 7, 7, plus 3 times 7, 21d. And that equals, because that's the sum of all the terms, that equals 756. And so looking at this, my first instinct is 7d squared, 21d, plus 756, to solve it as a quadratic. And hopefully they're all divisible by 7, because that would simplify things a lot for us. 256 divided by 7 equals 108. Yes. And so we have d squared plus 3d plus 108 equals 0. And so that means we can just solve it quadratically. Divisors of 108 are 9 and 12. Oh, that makes it a lot easier. So d... No, it doesn't. It's 9 and 12, but it can't end up with... Unless it is negative. No. Generally speaking, no. And if it was, we would be... Okay, let's just use quadratic function. So d is equal to negative b plus or minus the square root of b squared minus 4, a is 1, times 108 all over 2a, which doesn't exist. I guess I should put the a as 1. Just for myself when grading. So d is equal to negative 3 plus or minus. Okay, that's what I was thinking. But you'll notice when we get here, this ends up in a negative. So that means there's no roots. Does that mean there's no solution? Nope. Actually, there's one other way. And so basically, if we have a d squared again, d squared, our next term, since it doesn't specify that it's an increasing arithmetic sequence, actually our next one can be minus d. And so on and so forth, all the way to d squared minus 6d. And what does that change? Well, that means if we come back here, all that changes is d squared minus 3d plus 108 equals 0. And when that happens, we still can't do anything. Wow, I talked such big game. I thought maybe, because 9 times 12 gets us there. Oh, I'm so silly. Hang on. Oh, I did a big oof over here. When I moved it to the other side, I didn't make it negative. If anybody caught me there, haha, good on y'all. But, I did not, so let me change that. So 1, and then times negative 108. So that does not end up in a negative. But rather it takes us here. And so, yeah, okay, so now we can do it. Well, it would just be D and D. 108 is divisible by 9 and 12. One of them has to be negative because we have negative 108. So that means in order to get plus 3, we would have negative 9 and plus 12 in order to get our 3D. And so D is equal to negative 12 or positive 9. And that's our answer. Well, that's my answer. I wouldn't say our answer. But that looks to be about the only two possible values. Because, well, we're not exactly working with cubics or anything. So let's leave that as our answer. Okay, 4A. Liang and Edmundo paint at different but constant rates. Liang can paint a room in 3 hours if she works alone, and Edmundo can paint the same room in 4 hours if he works alone. Liang works alone for 2 hours and then stops, and Edmundo finishes painting the room. How many minutes will Edmundo... Okay, so this is a question of rates, because you can put this as Liang has a rate of 1/3 of a room per hour. And Edmundo has a rate of 1/4 of the room per hour. So if Liang works for 2 hours, 2/3 of the room is done. So we're looking for 1/3 of the room. How long does it take if we're dividing that 1/3 of a room by his rate of 1/4? So how many hours does it take for that? Well, if you've ever divided fractions, you'd know what we do is we change it to a multiply, and we switch the 4 up here, so it will be 4/3 hours. And so if we convert that to minutes, because the question is asking us for minutes, that would be, well, it would just be times 60. So 4 divided by 3 equals times 60 equals 80 minutes. So our answer would be 80 minutes. Okay. 4B. Let's open a new page for that. 4B. On January 1st, 2021, an investment had a value of 400. From 2021 to 2022, it increased by 8% and 8% again. No. The value of the investment decreased by 8% from its value on 20. Okay. So let's label this x1 as our 2021 value, and it equals 400. And then x2 is our 2022 value, and that equals 400 times 1 plus a, because it increased by 8%. And x3, our 2023 value, is equal to x2 times 1 minus a. So that's kind of how it goes, and we kind of just like treat it like a Russian nesting doll, and we nest each function into the other. And so x3 is also equal to 391. So 391 equals, well, let's substitute x2, right? So 400 times 1 plus a times 1 minus a. Okay. That's what I would do. But now that I've gone this far, it looks a bit tough. No, it doesn't. What am I doing? We just divide both sides by a. 1 minus a. 1 minus a. And we get a ratio through. So 391 over 1 minus a is equal to 400 times 1 plus a. I take it back. I do not know what I'm doing. Oh, wait, no. Wow, everything goes back to quadratics. Everything goes back to quadratics. So 391. Okay, let's expand this. So it's basically 400 times 1 plus a times 1 minus a. So let's take that, yes. Let's take this 400 and move it to the other side. So it'll be 391 divided by 400 is equal to 1 plus a times 1 minus a. And so let's expand this into a quadratic. So we'd have 1, and then we'd have, well, 1 times a, and then 1 times negative a added together is 0. So it'd just be 1 minus a squared. Oh, so it was a difference of squares question. That's my bad for not clocking that. Okay. And so 391 over 400. Let's move the 1, and then let's times everything by -1, because I don't feel like dealing with that. So we would get 9 over 400 equals a squared. So if we square root it, a is equal to plus or minus, keep that in mind, you must have the plus or minus of 3 over 20. I'm pretty sure that's the square root of 9 divided by 400 is that. Square root of such is, yep, plus or minus 3 over 20. And that makes sense because the plus a and minus a are the same, they're both multiplied, and order doesn't matter when they're all multiplied. So although it wouldn't make sense for somebody to say the value of the investment increased by -a%, mathematically it would make sense. So the answer is a equals plus or minus 3 over 20. That's my answer. And I guess, yeah, you could check it. If you do 400 times 1.15 equals, and then you also multiply it by 1 minus 1.15, so 0.85, you get 391. So that's our answer. Well, that's my answer. Whew, okay. I need to fix my shrimp posture. Damn. So 5a. 5a. Suppose that this long equation for some integer of n, what is the smallest positive integer for n of which it has no roots? Huh, that's actually not that hard. So the definition of an equation that has no roots is when we do the b squared minus 4ac, it is less than 0. So essentially what we're looking for is the value of n that makes this true. And we're looking for the smallest positive integer of n. So our b value is -2 minus 1 squared. 2n minus 1 squared. Oh, well, I guess I could just put it like so. And since you can do this, basically we're just looking for when this is. Well, no, the question, okay. I said that wrong. Basically, we're looking for when the function is invalid, and if you remember the quadratic function that we've used like 2 times so far, the only time it can be invalid is when the square root is trying to square a negative. So the interior of that square root must be negative, which is the b squared minus 4ac. And so basically all we're doing here is if we input our b value, and then we input our c value, we have no a value in this case, so that makes it a little bit easier for us. And so we have, I guess, a function. Don't mind me, I'm just eating a little something. Can't do that in a competition, but I'm at home, I do what I want. And so we expand this square root, not square root, square. It'd be 4nx, and then negative 4n plus 1, I think. Yeah. Minus 4n squared plus 88 is less than 0. Oh, that's nice. So this is going to cancel out. So we're left with 4n plus 1 plus 88. We want it to be less than 0. Negative 4n plus 89 less than 0. And although, you know, we have a less than sign, we can kind of treat it as an equal sign, but not quite. So we're going to subtract negative 89 from both sides. We have 4, negative 4n is less than negative 89. We can divide both sides by negative 4. But whenever we divide by a negative, when we have this inequality here, the sign direction does have to change. So now it's 4n is supposed to be greater than 80. Oh, I guess I took the initiative to divide. So it'd be n is greater than 89. 89 divided by 4, which is 22.25. The question is asking us for the smallest positive integer, which means n should be equal to 23. Because that is the smallest integer that still satisfies this inequality. So answer is n equals 23. So let's move on to 5b. Okay, in this diagram we have two triangles, of which PQ has a length of A, QR has a length of B, PR has a length of 21, and PQR is 60. Also, STU has A and B as well, and TSU has a 30 degrees. Sine of angle TUS, so this angle, is 4/5. Determine the values of A and B. Huh? Oh, okay. So first off, I guess I'm going to work a little bit on here just because it's easier. Well, yeah, you'd have to write it, but so sine of angle TUS equals 4/5. Sine of angle TUS is, so it's this angle. It doesn't really specify that this is a right angle, but I guess it's kind of implied since they're giving it to you. So it would be not helpful at all. Oh, you just use sine. No. Hang on. Oh, I see. So if that's sine of TUS is that. And that means sine of angle TUS equals the sine of 30 degrees over B over A. because this is sine law, right? We're using opposite side lengths. So we have kind of an in here where we do this. And so we have 4 over 5 over 5. And if we cross multiply, because I hate dealing with fractions, so it'd be this, and then sine 30 is 0.5, so 1 over 2a. So we have that relationship now, which means we also can work through here, I think. And so here we have sine 21, no. Is it cosine law? Because even though we have this, we don't have any of these angles to make use of sine law. I think it is cosine law. So cosine law is c squared equals a squared plus b squared minus 2ab times cos of angle C. If I'm remembering that formula correctly. I might not be, who knows? That's why you don't take me as the answer key, people. I don't. I know about as much as what I'm doing as you guys do. But yeah, so theoretically that's that. And we have angle C as in it's 60 degrees. And we can use this even though we don't know A and we don't know B, because we can substitute one of them with the other. So C squared is, I might need more space for this. I guess I do need more space. So let's start B continued. So let's go back to C squared equals A squared plus B squared minus 2A AB times cos of angle C. I shouldn't put 60 yet. C. So I have 21 squared equals, we don't know A squared yet, we don't know B squared yet, we don't know A or B, so let's leave it for now. Cos of angle C, which is 60. Okay, 21 squared should be like 441 or something, right? 21 squared is 441. And so this is where, we had that 4 over 5b equals 1 over 2a. This is where we choose what to do. I think I'm going to multiply both sides by 2. So now we have 8 over 5b equals a. And because we have a nice clean a, we'd have a over 5b squared plus b squared minus 2 times 8 over 5b times b times cos of 60. And so that's kind of how you would do it, I think, or how I would do it, how I think it should be done. Because now we have all b's, right? We only need to isolate now for one variable, which means it's solvable. So let's power through it. 441 equals, it would be 64 over 25b squared plus b squared minus, let's do this. I'm pretty sure cos of 60 would make it a little less tedious for me to write. Yes, because cos of 60 is 0.5, we can get rid of that too. So then it would be 8 over 5b squared equals still 441. Funnily enough, now we're left with only b squared, so let's combine all the like terms. So we have 1. Wow, this is a sucky number to deal with. It would be 64 over 25 plus 25 over 25 plus, well, it would be times 540, not plus, minus 40 over 25 all times b squared. You can do that just because they're all the same variable. And I'm just doing this. You could probably punch it into a calculator, but I just find it easier to lay it out like so. Plus 25. We're left with 59 over 25 b squared. So, wow, that is a number. And thus, we divide by 59, not 49, 59 over 25, divide by 59 over 25, which is essentially saying we divide by 59 and we multiply by 25 to get, that's a number. That is a number. Let's use fractions. So it would be 441 times 25 equals 11025 over 59 equals b squared. Actually, that doesn't look any nicer. I don't imagine they'd give us such... Usually math competitions don't like to give decimal answers. But I'm not seeing like a way, a different way to solve this. Let's just power through. Editing me, you can just tell me if I'm being dumb or not. So, square root of 11025 divided by, nope, 11025 divided by 59 equals a whole lot of yaps. So b squared equals plus or minus. Well, actually, in this case, it definitely can't be minus, just because the existence of a triangle implies that it can't be. So let's round to 4 digits. I prefer 4 digits. Usually 2 is like standard, but anyways, I'm gapping again. Why did I put b squared? That is b. So now that we have b, we need to go back and we need to find a. So 8 over 5b equals a. So let's just take 13.6698 and multiply it by 8 divided by 5 to get a. A equals 21.8717. So our answer, if we put it in a box, is a equals 21.8717 and b equals 13.6698. And I mean, that looks about right. It looks, I mean, obviously they're not drawn to scale, but to a certain extent it looks like it could be possible. We don't have any like crazy long lengths. Yeah. Alright, final answer. That's such a mean set of decimals if that's the actual answer. And it'd be kind of unusual. We don't have any short answer anymore. Okay, new page. 6a. A triangle of area is divided into such and such. What is the total area of the shaded regions? Have I done a question like this before? Let me see if I can get... Where on earth did the line tool go? On GoodNotes. Whatever. Okay. The way I remember you're supposed to do this question is... Nope. Give me a straight line. You kind of form this like triangle lattice. Because it's a a triangle with the same proportions, all triangles on the inside are similar. And so you can do this, essentially. Where you form this triangular lattice. I guess I didn't, it doesn't look very great. It's okay. It's okay. I'm gonna just do this then. Doesn't look good, but it's okay. We just need the amount of triangles. So it's 1 here, it's 4 here, it's 1, 2, 3, 4, 5 here. Why did I count 4? That is 3. And so this should be 7, and this should be 9. Are you seeing the pattern? Because I am. And this is 11, and this is 13, 15, 17, 19, and 21. Right? Let me just... 1, 2, 3, 4, 5, 6, 7, 8. Huh? 3, 4, 5, 6, 7, 8, 9. 9. Don't know how I miscounted it. But that's how many like teeny little triangles. And the principle of a fraction is 11? Yes. The principle of a fraction, right, is it's divided by little equal pieces. And so I don't know how I would, I guess since it's a long answer, I don't know how I would display my knowledge of this pattern. But the total of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21. 121 equal little triangles. Let me give my writing space back. Equal triangles. And of the 121, there's 1 plus 5 plus 9 plus 13 plus 17 plus 21. That's a total of 66 are shaded. And I guess, yeah, since they're telling us it's parallel, that's how we know it's a similar triangle. But I'm grading it myself. I'm not gonna bother with like the proofing and all that of like this triangle is similar. But it shares 2 side lengths, and the other side length is parallel, so I mean, yeah, it's similar. But so the area total is equal to 770 cm squared. The area shaded is equal to 66 over 121 times the area total, which means area shaded equals 66 divided by 121 times 770 equals 420. Ah, that's the funny number. That's our answer. This question, it wasn't complicated. It's just, I guess you need to know it. You need to know the concept. Something tells me I'm not going to know this concept. I've never seen a question like this before. A square lattice of 16 points is constructed such that the horizontal and vertical distances between adjacent points are all 0. Not 0, 1. All 1. And each pair of 4 points are connected by segments. The intersections of such segments are the vertices of square ABC. Determine the area of ABCDE. Oh my. Huh. Well, actually, what if I just made this a Cartesian plane? Yeah, what if I just make this, so let's name this line 1, line 2, line 3, and line 4. Okay, so line 1 has the chords of, say this is 0, 1, 2, 3, right? It has, and then 0, 1, 2, 3. Yeah, let's give this a try. Like I said, I've never seen anything like this. So line 1, it has 2 points. It has the points 3, 2 and 0, 3. And so it is y equals negative 1 over 3 x plus 3, I think. Yeah, that looks about right. It goes down 1, it starts at 3. And then line 2, do we have space? Maybe. Line 2 is, it has the points 0, 2, and 3, 1. So I'm pretty sure it is parallel, which means it's also negative 1 over 3x, but this time it's plus 2. Plus 2. Line 3, I'm skipping the points writing. You get the drill at this point, right? Like this, you get what the quadratic, not the quadratic, the Cartesian plane I made up in my head kind of means. But line 3 is y equals, well, we can clearly see it's got a slope of 3. Main thing is, where does it start? Well, it would start down here. Actually, let's pull up the points again. Just for clarity's sake, right, we have 1, 0, and we have 2, 3. So at 0, it would be negative 3. And line 4, we have our points 0, 0, and 1, 3. So our line is once again a slope of 3, but this time it's just 0. X-axis is just 0. And so our points are what? Well, our points are when these lines that we have found intersect. So let's just do them one by one. So A is when line 1 and line 3 intersect. So line 1, negative 1 over 3x plus 3 equals line 3, 3x minus 3. So it would be 6 on this side and 3, 1 over 3x on this side. X would equal, oof, that's going to be a very ugly number. What if I just, hang on. So through, that'd be plus, yeah, so it'd be 9, 10 over 3. I would like to keep exact numbers just because we're going to be doing so many calculations with these numbers that I don't think we should use decimals. So times 6, no, not times 6. It'd be divide, so 6 divided by 10 over 3 is the same as 3 times 6 over 10. So it'd be 18 over 10. And then our y is, well, 3 times 18 over 10 minus 30 over 10, 24 over 10. I think. Right? 18 times 3 equals 540 minus the 30 of a whole number. Yeah. So that's point A. Oh my. I did this to myself of my own free will. I decided this is the this is what I'm going to be spending my time doing. Point B is when line 3 and line 2 collide. So line 2 is negative 1 over 3, 1 over 3x plus 2 equals 3x minus 3. Yes. Yes. So once again, we go back to our little silly ways and we find ourselves, well, we have 5 on this side and we have, once again, 10 over 3 x. X is equal to 15 over 10 equals 3 over 2. Let's keep it at the 10 for now, just because even though it's more annoying to work with, it's probably going to be easier to convert later. So then we have to find a y, so 15 times 3 is 45, minus 30 is 15. Huh. Is it really? 15 over 10? That looks right, to be honest. Okay, yeah. So this is our point B. We're getting somewhere. We're calculating all these points for a reason. And the reason is because later, then we're going to use these points to find the length of the segment. But we'll get there. We'll get there. And so point C. Point C is when line 2 and line 4 meet. So it's when 3x for line 4 is equal to line 2, which is negative 1 over 3, x plus 2. So then it's once again 10 over 3, x is equal to 2. X is equal to 6 over 10. Right? Because 6 over 10, yes. And y would be equal to 18 over 10. Do we have an 18 over 10? We did, but not, okay, not that. And then point D. I don't think I have the space, but I don't want to, this is not the time to be trying to figure out where the lasso tool is, but where did they move my precious lasso tool? Sorry, I'm crashing out over technology changes like a boomer. So line 4 and line 1 meet to make point D. So it'd be equals 1 over 3 x plus 3. There's no space. It would be the same. It would be 10 over 3 x equals 3. X equals 9 over 10, which looks about right, and y equals 27 over 10. My goodness, that's a lot of numbers. So let's open a new page. So let's transfer all our points. So we have point A, which is a lovely 18 and 24 respectively. 18 over 10 and 24 over 10. point B is 15 and 15. 15 over 10 and 15 over 10. Point C is, what was it? 6 and 18. 6 over 10 and 18 over 10. Point D is 9 and 27 respectively. 9 over 10 and 27 over 10. That's a lot of numbers. Too many numbers. I guess this whole time I could have just been used. It's over 10. I guess this whole time I could have used decimals. Oh my gosh. This whole time I could have just used decimals. I am going to... I'm not going to say the thing, but... Okay, so it's 1.8, 1.24, and 2.4, and 0.6, and I forgot that number, 1.8, and that's 1.5 and 1.5, and that was, I believe, 9, so 9 and 2.7, 0.9 and 2.7. I could have done this. It would have been so much easier. Okay, anyways. Let's talk lengths now. Now that, well, we are told it's a square. We're told it's a square. Oh my goodness. We're told it's a square. We were told it's a square, which means I only needed 2 of the 4 points after I calculated all of them. Anyways, let's do length AB. Length AB, if you visualize it, is the hypotenuse of the distance in, well, that would be y. So the distance or change in y and the distance of x, which means we would use the Pythagorean theorem of 1.8 minus 1.5 squared plus 2.4, well, yes, order usually does matter. It wouldn't really matter in this case. 2.4 minus 1.5. The only main thing is you have to use the difference. I guess order doesn't... Well, you want to put the first one in the first one. I take it back, it does matter. Still not really. Who cares? Order matters, let's just put it that way. If you have the mind space to do it, make sure you do it, and then it would all be squared. Square rooted, I mean. So length of AB, square root of all that. 1.8 minus 1.5 equals, squared equals 0.09 plus, let me guess, that's also going to be some, I'm not gonna say that, I'm not gonna cuss. Length of AB is the square root of 0.9. And I would leave it here because it's a square. We'll ask the area. So area of ABCD is equal to AB squared. ABCD is equal to square root of 0.9 squared is equal to 0.09. Not 0.09, 0.9. Yay! That's our answer. I didn't need to calculate 4 whole points. We were told it's a square. We were told it's a square, so I could have found two. I only needed 2 points. I would have only needed to calculate 3 lines and 2 points. Whatever. Whatever. Wow. Okay. If I don't get this question right, I don't know what I'm gonna do. I'm gonna be mad. Not that anyone will know. I'll just be mad in my own room, I guess. I'll be mad and I'll be huffing and puffing, but nobody will know because obviously nobody will record it because hell I'm not. And nobody will know because I'm in my own room and nobody will witness it. Anyways, a bag has 3 red marbles and 6 blue. Akshan removes 1 marble at a time until the bag is empty. Each marble they remove is chosen randomly from the remaining marbles. Given that the first marble Akshan removes is red and the third marble they remove is blue, what is the probability that the last 2 marbles that Akshan removes are both blue? Okay, so we know for sure 1 red is here. So we know for sure term 1 is a red, and we know for sure term 3 is a blue. So here we have 2 cases. We have a 1 in, well, how many marbles are left? We have 2 red and 5 blue left. So 2, 5, 7. We have a 2 in 7 chance that what's taken is a red. And we have a 5 in 7 chance that what's taken is a blue. Oh, this is going to look so bamboozling. Okay, let's just start with reds. Just start with red. So we have a 2 in 7 chance that what's taken is red. And then on our, so this is 2. And then on our 4th, we have a 1 in 6 chance that what's taken is red. And then that means automatically all we have left is blue. We also have but instead we also have a 5 in 6 chance that was taken as a blue, which means we have to continue on. Which means now we have a 1 in 5 chance was taken as a red, which means we can just carry on because all that's left is blue. So that's 2 over 42 chance, and this is a 10 over, well, we'd cancel out the 5, so it would be 2 over 42 again. Our next one, so 6th marble removed of the 9. Sorry, had to crack my back there. So we have our 5 out of 6 chance it's a blue, and then we have a 4 out of 5 chance that it is blue, which means now we have a 1 out of 4 chance that we pull a red. Oh, I'm starting to see a pattern. And so it's still a 2 out of 42 chance. And then 7 is our last chance because the last 2 have to be blue. And so we'd be 1 out of 3. So then it would be 3 out of 4 chance we pull a blue, 1 out of 3. Let me guess, it's 2 over 42 again. So that's it for if we pull a red at the start. So that's 1, 2, 3, 4. That's a total of 8 over 42. makes sense. Well, huh. 7, 6, 5, 4, 3, 2, 1. 2, 1. So the last two have to be blue. So those are the only cases that the last two are blue, if all the reds get eliminated ahead of time. So let's go down now to our, oh, I drew that too far, to our first divergent path, just because I needed the space. But what's going on? So let's say we don't pull a red. So we have a 5 and 7 chance that we don't pull a red and we pull blue. And now we have a 2 out of 6 chance that we pull a red. If we pull a red, then obviously we still have one more red left. Oops. And so it would be a 1 in 5 chance that we pull a red, which, let me guess, is still 2 over 42. It is. It's still 2 over 42. And then it would be 4 over 5. And then 1 in 4 chance, it would still be 2 over 42. Looks like it. Looks like that's the pattern. Okay. The only difference is now it starts a little later. So it would only be 3 times. Right? Because it would be here, which I have done horribly at keeping aligned. Yes, 1 out of 3. So that's it. So it's 6 over 42. They don't ask for the to show your work, so that probably just means they wanted us to do it like so. And so it's 6 plus 8 over 42. That would be 14. 14 over 42 is 1 over 3. Right? 1 over 3. Yes. That's our answer. Wow. That's a brain workout. As if all the rest wasn't. No, the rest was a brain workout too. Determine the number of quadruples of positive integers with a, b, c, and d that satisfy the following systems of equations. Huh. At first glance, I have no idea how to do this. Positive integer is such and such. Well, you could. Or would it be a plus b times c plus d? Right? Because A, C, A, D, B, C, B, D equals 2023. And then A plus B equals 296 minus C plus D. Would that not be how it goes? And so then, if we, I want, oh, there's a lasso tool. Okay. I see the pathway. So, well, that got cut off. So then A plus B is equal to 296 minus C plus D. And so therefore, if we substitute this, we would have 296 minus C minus D times C plus D. I don't think that would, well, we still have two variables. We'd still have two variables. I feel like there has to be some kind of like pairing system. Because 2023, is it not a prime number? It feels like a prime number. I have no proof. Oh, it is not a prime number. So 2023 is divisible by 7 to get 289. 289 divided by 7 again? No. 289 divided by 11? No. 289 divided by 13? No. That might be it. $289 divided by 17. I take it back. 17 and 17. I'm seeing a little bit of a pathway. Because factors for 2023 are so limited, I think we'd have to use this. And so if C plus D equals 6, not 6, 7, right? Then we would have 7 times 296 minus 7 is 289 equals 2023. There we go. So C plus D equals 7 and A plus B equals, well, 289. Now, hold on. now we're in a new dilemma. C and D must be greater than A and B. So this is like basically fundamentally impossible. However, realistically speaking, A and B and C and D are exchangeable. And so if I go back and I substitute A and B so that we have A and B here, and therefore end up here with A plus B and C plus D. There we are. So how many quadruples are there? Well, we are in the positive integers, so it's not infinite. And so that means the lowest A can be is 1. So 1 and 6, 2 and 5, 3 and 4. So that's 3 options for A and B values, because A can never be greater than B. For C and D, the lowest C can be is 7, which means D would be 285. 2. The midpoint of 282 and 7, 282 minus 7 equals, divide 2 equals 282 minus said answer. So the midpoint is 137.5. So it would be 138 and 137. Theoretically, I don't think that's right. That's theoretically a midpoint. Is that just a midpoint? $282 minus 137 is 145, and 7 plus 137 is 144. Okay, so 144 and 145 are 137 away from each other. So I'm pretty sure that's 138 pairs, right? $144 minus 7 is 137, but we need to include the 7, so it is 138 pairs. So it would be 3 pairs, or 3 sets of values possible for A and B. 3 times 138 equals 414 pairs. Sets, quadruplets, whatever you want to call them. Sets. I hope I'm right, because that... I feel a bit proud about that. This is something I feel like grade 12 me would have never gotten. Alright. 8A. We're probably entering like the ones that I definitely cannot do at this point. Suppose triangle ABC is right angled at B and has AB and AC. Determine the number of positive integers for n is less than that, for which BC is also an integer. So we have a triangle here. Let's draw it out. Where we have a right angle at B. So AB is n plus 1. Suddenly I'm so congested for no reason. And AC is n plus 1, n plus 4. Where n is a positive integer. Determine the number of positive integers for which n makes BC an integer. And theoretically, this isn't complicated. If we take AC, so it's definitely AC squared equals BC squared plus AB squared. And AC is n plus 1, n plus 4 squared equals BC squared plus n plus 1 squared. But this is probably where it gets messy, where we have plus 5n plus 4 squared equals BC squared plus n squared plus n also squared. So then it'd be BC squared plus, basically that'd be n squared plus n times n squared plus n And on this side, it'd be n squared plus 5n plus 4 times n squared plus 5n plus 4. So bear with me as I do this. We'd have n to the power of 4 plus 5n to the power of 3 plus 4n squared plus 5n to the power of 3 plus 25n squared plus 20n, and then plus 4n squared plus 20n plus 16. And so on this side we have n to the power of 4 plus 10n to the power of 3 plus 8 plus 33n to the power of 2 and n. 20n? That's not right. Yeah, plus 40n plus 16. What a mess. But looks about right. Equals. OBC squared is still here, plus n to the power of 4 plus 2n to the power of 3 plus n squared. Right? Such. Yeah. So basically I just expanded out all this nonsense, and so that leaves us with quite the mess to work with. But honestly, at this point, we can just get canceling. Cancel, cancel, cancel. So the n4 gets canceled, 2n on this side, so it would be 8n cubed. The n squared would cancel a measly 1n. But the nice thing is that in doing so, would you look at that, it's all divisible by 8, which we're not going to divide so much as we're going to just kind of drag it out. Equals BC squared. And so we need to find ways to make this valid. You know, we can always go back to good old long division, because probably what we're trying to do is we're trying to factor this. Where maybe we aren't. But I would like to try. I have no idea what to do, so I'm just going to try. Right, so we have n cubed plus 4n plus 5n plus 2. Let's try dividing it by n plus 1, where we would have n squared, so we'd have n cubed plus n squared. We'd have 3n squared left plus 5n. That will be plus 3n squared plus 3n. We have 2n plus 2 plus 2, 2n plus 2. Perfect. So it'd be 8 and then n plus 1. And when we're left with n squared plus 3n plus 2 equals bc squared. 8n plus 1, it would be n plus 1, n plus 2, bc squared. Wow, that cleans up nicely. So because let's say we square root this, right? If we square root this, we'd be left with 2 on the outside and n plus 1. And on the inside, we'd be left with 2n plus 2 equals BC. So in order for BC to be a whole, was it a whole integer? Yes. In order for BC to be an integer, we don't have to worry about this anymore because it's whole. Except, well, as long as n is whole. But we need to worry about this. And so n plus 2 must be perfect times 2. So perfect times 2. So n can start from 2. If n equals 2, then the inside is no. Hang on. It must be a perfect square times 2, which means that 1 is not possible. So it must be 2 times 2, which is 4. So it must be 4 times 2, which is 8, so n must equal 6. If n equals 6, then n plus 2 equals 8. 8 times 2 is 16, which is a perfect square. What is the largest one we can do? Probably... don't know. Well, let's... how do I find the last value? Well, actually, the last one is probably... no. Huh? I actually don't know now. Because... obviously, this one we absolutely cannot count all the way up. Can we? Do we need to? Because it'd probably get exponentially higher. Well, okay. So this is to get 4. The next one is 9. Times 2 is 18. N would equal 16. And the next one would be 16 times 2 is 32. The next one, n equals 30. And then the next one is 25. 25 times 2 is 50. 25 times 2 is 50. 50 minus 2 is 48. 10, 14, 18. I mean, that is a pattern. Oh boy. Am I gonna have to play the, like, counting game? No. Surely I can make a formula. So then it would be, so n1 is equal to 6. So, okay, it would start at 0. Because it would be plus 6. So if it does that, it'd be 6 times however many, and it would be there has to be a way to find the number of possibilities without counting every single one. I'm just not sure how. Because there is a pattern, I'm just not sure how to express the pattern numerically. So it would be plus 6 every time, plus 4 times the number of thingamabobs before you. But that's just the increase of one term from the previous term. So it would be n1 equals that, n2. But then, how would you... I'm gonna put this as a come back or give up. I'm definitely missing something. Probably my knowledge, given, I haven't done these in a while. But there's definitely, like, some key piece of knowledge to this part that I don't have or don't know how to use. Probably geometric sequences. Oh, this would be a geometric sequence. I was never good at those. Those things boggle my brain. I don't know it though. It was like 1 plus R? No, 1 plus R wouldn't make sense in this scenario. Alright. Nope. This is a... Call it a day. Maybe I'll get part marks. Because I'm pretty sure... Doesn't CMC give part marks? I don't quite remember. I think it gives part marks. So yeah. Anyways. Determine all real values for x of which. It's late. It's late and I chose to do this. Anyways. Suppose all real values for x of which. My first instinct is square everything, but I'm pretty sure I cannot do that. I'm too tired for this. I think. Well, no. Let's take a look at 9. Something tells me I might have to call it quits early. And by early, I mean it's not that early. It's been 2 hours almost, so it's not bad. It's not bad. From the start, it's not typical that you would be able to solve everything. Especially not from average Joe here. But at a Canadian eatery with multiple configurations, There are round tables which chairs are placed. Each table, when a table has n chairs, the chairs are labeled such and such, 1, 2, 3, 4, all the way up until n. Around the table, a table is considered full if no people can be seated without having two people sit in neighboring chairs. And such. Okay, so let's give this one a try. 9a. We have 1, 2, 3, 4, 5, 6, 7, 8 seats. And we're looking for all the ways they can be seated such that. So 1, 2, 3. And 1, 2, 3, 4. So those two sets, those 3 people and 2, not 2, 4 people. For 3 people, we can kind of center it around the seat that gets squished. Let's say that. So there are 8 sets. Yeah. 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 For 4 people, there's 2 sets. 2 sets. For a total of 10 sets. Oh, I need to give the labels. Okay. So it'd be 1, 4, 6, 2, 5, 7, 3, 6, 8. And then it would be 4, 1, 7, 5. No. Well, this would be 1, 3, 5, 7. And this would be 1. Nope. 2, 4, 6, 8. So 3, 6, 8. So the one that was squished was 7. So the next one will have 7. And the opposite is 4. So 4, 7, 1. And then it would be 5, 8, 2. Yeah. And then it'd be 6, 1, 3. And then it would be 7, 1. No. 7, 2, 4. 1, 2, 3, 4, 5, 6, 7. And then it'd be 8, 3, 5. No overlap? No overlap. And so that's our 10 sets, I suppose. For a table with 6k plus 5 chairs, for some positive integer of k has t seated people, determine in terms of k the number of possible values of t. Would it not just be 2? A full table is such, and for some positive integer of k has t people seated. Well, when you have 1, 2, 3, 4, 5, 6, 7 seats, 1, 2, 3. You only have a possibility of 3. And so if your seats are 6k plus 5, t is equal to 3k plus 2, is it not? That's it. Because if it's odd, it only has the possibility of sitting like so, right? Because if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. So it would be whatever the odd number is minus 1. That's it. Determine the number of different full tables when n equals 19. I'm fairly certain. 1, 2. I am fairly certain it's just 19. 9c. Let's give it a test trial. So 1, 2, 3, 4, 5, 6, 7. You have such a set. And so 7's your odd. And then you could do this. And so you'd have 7 sets. So it's just 19 sets. That feels too simple. It's not asking for the different sets, it's just asking for the number of different full tables. We're moving on. Editor me can say if I'm right or wrong, I suppose. But so 10 is supposed to be like the big chungus of math questions. Difficult, and usually nobody's supposed to actually solve it. They're just looking for your work and to see how far you got in the right direction. Something tells me we're not going to get very far. For every real number, define whatever this weird symbol of x to be equal to the greatest integer less than or equal to x. Oh, the floor of x. So whatever is inside, we round it up to the nearest integer. No, we round it down to the nearest integer. So for example, 4.2 is 4, 5.7 is 5. Okay, 10a, 0, 0 plus 1 plus 1 plus 2 plus 2, all the way up to plus 20 plus 20. So let's say this is 40, and let's say this is 2. We have 60 terms, one of which is redundant. I take it back. That's not how we do it. Because the next term would not be 2. The next term would be still 1. Because it round down. Plus 2, plus 2, plus 2. So that's 3. The next one would be 6. And the plus 40 is by itself. It is not part of the pattern because it doesn't have one that rounds down. So we have a total of 57 terms that follow this pattern here. So 57 divided by 3 is 19. So up until the end, we have 19 plus 19 plus 19. So 19 plus 19 plus 19, 57, and then plus 3 is 60, but that's not the point. The point is that we have 57 terms. but we don't exactly have 57 terms because we are grouping them in groups of 3. Rather, instead of uh, groups of 3, so instead of 57 terms, we have 19. And we shouldn't be dividing, we should be multiplying because we're looking at the sum of. Wow, I'm getting tired, can you tell? So it'd be 19 times 60 equals 1,140, and then plus our 40 that is by itself, so our total equals 1180. I had forgotten about the fact that they usually make 10A easier so that we give it a try. I forgot about that. So do not think I'm some... Why am I policing people on their opinions? But it's not a crazy feat to get 10A. Typically, they make it easier so that it boosts students' confidence. They're like, yes, I got 10A. Let's give 10B a try. Because ultimately, the goal of a math contest is not to make you feel dumb, but rather um, hmm? Sorry, I lost my thought. Wow, I'm tired. Okay. Whatever I was saying, I'm sure editing me will finish my sentence, I guess. I don't know. I'm counting a lot on editing me, despite the fact that I've never edited before in my life. Well, I've done a bit, but nothing crazy. Okay, determine a polynomial for p at x so that every positive integer of as long as m is greater than 4, p at m is equal to such. I feel like I kind of did that, but also I don't know how to translate it. So the first one is always 0. We know that. Given that... Okay, let's see. So the first term is 0. The next 3 will be 1. So we can't really average things out because there isn't stable growth. I think I think I'm calling it quits. um to anyone who's doing this out on their own, you know, you've got 25 minutes left. But I'm clocking out. If I was in the contest, I would like fill out my answers, double check it briefly, and then just hand it in. This is what I like. I don't think call it quits is a word. Just it's not even cut my losses. It's just throw in the towel. That's the word. Okay, this is where I would throw in the towel. Had a lot of fun. I'm surprised how much of my math ability I've managed to retain, given, you know, I haven't done these in like I don't want to say how many years because it reveals my age, but several years. And well, okay, yeah. Um, Thank you to anybody who's been here this whole time. uh, I don't really have any eloquent words to say just because, well, my brain is a little fried. Hopefully, editing me, post editing, will have something more eloquent to say. Probably, I'll just be cranky at myself for the amount of things I've told my own myself in the future to fix, but thank you to anybody who's been watching this video. I hope it achieved what you came here for. You know, if you were using this as funky background music, I hope it was calm enough to do whatever you wanted it to do. To those who did it alongside me, feel free to, share how you did. If you if you realized I did something wrong, feel free to let me know. If there's anything you want improved, changed, or whatnot for the next time I do this, let me know. If there's a different contest you want to do, feel free to leave a comment and just yell at me. Um, but yeah, have a good day or night or whatever time it is. I hope you have a good one and take care.